Proving lines are parallel. Okay, so the first problems in this section basically just want us to, or it's asking, can we prove that the lines are parallel, and if so, like, what allows us to do that? Pretty much in every case, it's a converse of something that's going to, if it is possible. So they give us two lines. Again, when you're doing your homework, you should be copying the pictures over for these, just like we've been doing. So this is the information that they have given us. So they've shown us that this angle is congruent to this angle, and it wants to know, can we prove just purely off of this information given that these lines are parallel? Are these alternate, are they corresponding angles? Are they alternate interior angles? Are they consecutive interior angles? Or are they alternate exterior angles? No, they're none of those things, right? So can we prove that these lines are parallel just off of what they gave us? No. What are the angles that they gave us? Yeah, they're vertical angles, which doesn't tell us anything other than we know they're congruent, but it doesn't tell us anything about lines being parallel. So that one we would just write no. Basically, there's no way we can prove that they're parallel. 6. All right, so we have these two things given. So they're not showing us, like with the little circle thingies, that these are congruent, but we know that obviously 62 is equal to 62. So what are these, and can we prove that these are parallel lines? Yes, and we can do it by the alternate interior angles converse. This is a key thing here. Okay, you have to write converse because we also have the alternate interior angles theorem from earlier on. So if you don't write converse, it's not going to get full credit on that. 10. Again, is it possible to prove lines imminent or parallel? If so, state the postulate or theorem you would use. So it's basically the exact same instructions. It just jumps down a section. So these lines go up and down like this. Transversal's going this way. All right, so can we prove that M and N are parallel to each other? And if so, how? Yep, exact same reason as the previous one. Alternate interior angles converse. Um, 12. On this one, they give us these two angles. Can we prove that these lines are parallel with the given information?
Yes.
Yep. So yes, the corresponding angles converse. So if those are congruent, then the lines have to be parallel. All right, find the value of x that makes r parallel to s. So again, they give us a picture. Now, unlike the one that was in the PowerPoint slide, when you're solving for it, you only need to solve like for x. Like you don't need to show what, like say 2x ultimately is equal to. But I am, label these. I want to find a value that would basically require R and S to be parallel. So for R and S to be parallel, what has to be true of x and 2x?
They equal 180.
Yep, they add up to be 180. This seemed to be what we were having trouble with when we were doing like quiz review and stuff. These angles in here add up to equal 180. Okay, they're not congruent to each other. A lot of you are setting them equal to each other. They have to add up to be 180. So then 3x is equal to 180. So x is equal to 60. And that would be your answer on that one. So if x is 60, then R and S are parallel lines.
Do we have to write that?
What?
If x is 60,
N- No. I'm just explaining why it has to be that way. 18. What has to be true of these two angles if I'm going to prove that R and S are parallel lines?
They equal each other.
Why?
The alternate interior angles converge.
Yep, they're alternate interior angles, so they have to be congruent if the lines are going to be parallel. So, subtract 2x over here. 20 is equal to x. So again, I could obviously plug those in.
turning in my homework.
I could obviously plug those in, but I don't have to.
And also, is it okay that I got a decimal for it?
Yes,
Okay.
that could happen.
Alright, just making sure.
I mean, I don't know if that's right off the top of my head, but
I don't
it
know
is
either.
possible. All right. Feel like it's the same thing, different section. Is it possible to prove that lines A and B are parallel? If so, explain how. So 20. Got lines going up and down. Transversals going through this way. This is 37 and this is 143. So with the given information, can I prove that, this is A and this is B, lines A and B are parallel to each other?
Yes.
Why?
What was it called again? Consecutive interior angles converse.
Yep. So if 143 plus 37 is equal to 180, which it is, then obviously if those two things have to add up to 180, then by the consecutive interior angles converse, the lines are parallel. Let's see. This one's interesting. 22. Alright, so this one's a little bit different. It's not just two lines and a transversal. We have an extra ray on here, which is causing it to form two different angles. So, based on the given information, can I say that if these lines are parallel? Or are these lines parallel given the information that I have? What has to be true if the answer is yes, for those of you saying yes?
That we can
Equal 180.
What does?
One, up one.
106 and
Got it.
49. 49 is 54.
So 49 and 54, right? That would add up, and then we would have alternate exterior angles. Well, what's 49 plus 54? 103, which is not equal to 106. So those angles are not congruent. So the answer to this one is no. So these two would have to be congruent to this one, but they're not. So that's why. Take that away because it's going to get confusing. Well, I was gonna skip this one, but I don't want to skip this one. 24. Two lines going this way this time. And instead of it being directly a transversal, it's almost like they've drawn a triangle in here to an extent. And all of those that I just wrote in, they're tiny, but they're 60s. So can I prove that A is parallel to B on this one? How?
Consecutive interior angles, contours.
That's part of it, but what else do I have to have before I can do that?
And add the 180, it will be congruent to each other.
So first of all, I would have to show that these two add up. 60 plus 60 is 120. Then I can do consecutive interior angles. The 120 plus the 60 from down here is equal to 180. So first I would have to have the angle addition postulate. So this one requires two things. And then down here, consecutive interior angles converse. So this one required two things to be able to get there. So some of them, not many of them, but a few of them may require you to actually do two steps instead of just one to get there. All right, we've got a couple proofs. I'm leaving one of them that's just a fill in the blank proof, even though it's an even one for you, and I'm going to do the ones that aren't just fill in the blanks. 30. Write a two-column proof for the alternate exterior angles converse that says if two lines are cut by a transversal so that the alternate exterior angles are congruent, then the lines are parallel. So they give us this picture. G and H, transversals going this way. So I'm proving the alternate exterior angles converse. So I can't use that. I can't use it to prove itself. So I'm going to have to use other things instead. And the given information is that angle 4 is congruent to angle 5. I'm trying to prove that G is parallel to H. So statement, reason. So, first thing is always what? Given. Angle 4 is congruent to angle 5. That's a piece of given information. What else from this diagram do I know has to be true?
Angle 5 is congruent to angle 6 because of the corresponding angles converse. I think.
Or angle 4 is congruent to angle 6 because of vertical angles.
Yeah. Technically speaking, yes, we could say angle 5 and angle 6 are congruent. That would also be fine. I was leaning towards going angle 4 is congruent to angle 6. If you show 5 is congruent to 6, though, you're also going to have to show that 6 and 4 is congruent. We're proving, yeah. I would do it this way with the vertical angles theorem, because otherwise you're going to have to show other pieces of information. So then, based on that, what can I say?
Angle 5 is congruent to angle 6.
Why? Yep, transitive property. So then, ultimately I can say what?
G is congruent to H.
Yep, parallel.
I'm stupid.
Corresponding angles converse then. Yeah, you would need to do it in this order in order to get to the right final result, since we're trying to prove that those lines are parallel. All right, the next thing here, I have one problem left. Can you wait? Okay. 34. We're given a diagram again. Or wait, sorry, that's K, not H. And transversal here. So this one doesn't tell us that we're like trying to prove a particular theorem or anything like that. We're just trying to prove that J and K are parallel to each other. We're told, or the given is that the measure of angle 7 is equal to 125 degrees and the measure of angle 8 is 55 degrees. And we're trying to prove, again, J parallel to K. All right, so this is one that the book actually writes as like a paragraph proof, but we're going to set it up as like a 2-column proof, which tells me that 35 that you'll be doing is going to be written the same way, that you'll need to make it a 2-column proof, not a paragraph proof. All right, so start out with the given. The measure of angle 7 is equal to 125 degrees, and the measure of angle 8 is equal to 55 degrees. Any ideas on what my next thing would be given with the picture that I was given and knowing that I'm trying to prove that J and K are parallel?
The measure of angle 7 plus the measure of angle 8 equals 180 degrees.
Yep, measure of angle 7 plus the measure of angle 8 is equal to 180 degrees, and why is that?
The corresponding interior angles converse.
Definition of
so the corresponding converses would be proving that the lines are parallel. Well, and they also aren't corresponding technically.
Is it the definition? So,
So they are supplementary angles, but well, yeah, we could say that. Whoa, I can't spell. So then, based on that, what else do I know then? Or what can I say then?
125 degrees plus 55 degrees plus 180 by the substitution property.
Yep, 125 plus 55 equals 180 by substitution. So what can I say now to wrap it all up?
You use parallel decay.
Why? What are these angles?
consecutive interior angles.
Yep, consecutive interior angles converse. All right, so problems then for this section. Um, 5 and 11 through 25 odd. 28. 31 and 35. Now, before anybody has a conniption, because that's a lot of problems, I most likely will not be in class tomorrow because I have to go to a Metro conference meeting in place of Coach Holland that he can't go to. So, I will have a sub tomorrow. So, tomorrow during class, these will be your problems to do. I will leave backup work in case you guys decide to not work and all the other stuff. It is due at the end of class tomorrow. But you should have more than enough time to do these problems and turn them in by the end of class.